Fuck it, let's go. Hello and welcome to another Solana tutorial. I'm actually not sure if this is much of a tutorial, but it's Andy's gonna try and understand how stuff works around here kind of video. In particular, I wanna understand this thing. That's a Keystone wallet. It's a hardware wallet like your Ledger. Not a sponsor, by the way, otherwise I couldn't say Ledger. Ledger. Keystone. Solflare. I got this at Breakpoint from Solflare, thank you. But they're not sponsoring this video. This is a I wanna learn about this video. That's why I'm making this video. So yeah, bunch of branding. How can I get more branding in this video? I could still wear a hat. No, point being, this hardware wallet, right, that's where I was going. Hardware wallet. One feature that I really like about this is the Airgapped mode. So basically, I can do everything without having to plug in this wallet. So the seed will just be on there. And since I don't plug it in, the chances of it getting hacked somehow are relatively low. Because all it's doing is sharing information via QR codes through cameras. This thing has a camera, I have a camera, and then we can, scan stuff. If you want to send me Sol, you can just scan this and I shall receive that Sol. That's how QR codes work, right? So this QR code here encodes my address. Actually does it. And in order to see what it actually encodes, I have an app on my phone. It's gonna be a weird way of using, several devices. But yeah, that's literally just text, which is my wallet address. Starting with ndocs, because for this demo wallet, I actually grinded myself a key that starts with ND, in case you're wondering how I get such a nice address. But yeah, this is my address on here now. That's still the boring part. The more interesting part comes when we actually use it to send transactions. And let me just quickly demonstrate that. I will need a wallet. Let's add a Keystone wallet. It works with QR codes. So I need to allow this thing to use my camera, but my camera is already in use because I record. There we go. Now I'm in here and I'm blurred. On my wallet, I need to say connect, and then you get to see this, which you don't really get to see because it's blurred. And basically what that did, welcome back to out of the blur. Basically what that did is it shows a few addresses. However, it is not using my derivation path. This is already the first thing that I find a bit annoying. NDTN is also a nice wallet though. I'm gonna use this one. I also need to change the derivation path here. Then hold on. Here, I show you all my wallets. There we go. Here I find the Endo. Continue. So now I have this Endo wallet here as my Keystone 1 wallet, and it ain't got no Sol. However, I could go to DevNet and then see if the faucet gives me some Sol today. Can I has one Sol, please? Yes! Okay, and now I has one Sol, hopefully. Yes, rich. It's DevNet Sol. And now comes the interesting part, because now I can be like, send, I don't know, 0.01 Sol to, it doesn't matter, the other Keystone wallet that I found on the other path. Send, and that now gets interesting because if I say confirm here, it will display me a QR code. And if I read that QR code with that little wallet thingy here, then I get to see, oh, it transfers 0.1 Sol to that other address, and I can swipe to confirm. I need to type my password, and then it shows this thing, which is a QR code that in the next step, I gotta disappear again here. There we go. Then it's confirming that transaction. Maybe I was a bit too slow because block caches expire after a minute. But that's how my signature then gets to my Solflare wallet in the browser completely air-gapped. Like I never connected this. Okay, let's do it once a bit faster. Scan, swipe, show QR code. The other one errored. And this one, yes, this time I was fast enough. This time it actually worked. The thing with the block hash, it's a bit annoying because it puts you under pressure unnecessarily. The alternative is to use nonces, but I also don't like that. But yeah, here we see I sent from my wallet that I just have on here except I also have the seed somewhere else, but don't tell anyone because it's for demo purposes anyway. I'm just working on DevNet, it's fine. And I sent to this NDT need T, just a little salt transfer. Pretty simple. So now to the what I actually want to do today, because I just find that so interesting and I want to know how that works. And I want to be able to do that myself. Because for now I'm relying on Solflare, or Backpack also supports it, but I'm relying on them to, you know, build that transaction and display this QR code. I want to know how I can build this QR code myself in order to be able to send any transaction with my Keystone wallet in Airgapped mode. This is what I want to figure out today. I think that's a nice little challenge, just learning how all those protocols work. It is Solana related. It's nothing Solana native, but for me to feel confident in using a Keystone wallet, I want to be able to do that myself because, you know, just in case Solflare ever goes down or decides not to support that anymore, I still want to be able to use it, you know? That's part of my security policy. So today we want to figure out what those QR codes are, how we can create them ourselves, and how we can make that wallet send transactions that we build ourselves. So step one for this is to figure out what's there. So I'm gonna use my phone again and scan this QR code, and then I see this. I'm gonna copy it somewhere so that you also see it. I'm gonna paste this here. This is what the QR code says. So it seems to be a text QR code with this. So I see Sol sign request. That's already promising. And then maybe let's also look at the other thing, the transfer Sol signature, because that's what this thing then shows. If I scan this, then I sign, then I get this, which, if we scan this, looks like that. So that's a Sol signature. And it's pretty short. Yeah, they probably really just transfer back the signature, which makes sense because the signature is all we need. If the transaction is somewhere in here and we just give back the signature, that's all that we need in order to send that transaction. Solflare will still remember that transaction and it just adds the signature for us, and that's Gucci. Okay, so all we gotta do is be able to build this. So let's try and find out what that is. You are. What are you? You are what? Let's see what we find. We have Keystone HQ, Ethereum QR code, data transmission. So it's probably not a Solana thing. They probably use the same protocol for Bitcoin and Ethereum and everything. That makes sense that it might be Ethereum QR code data transmission protocol. Keystone HQ seems official. Specification, offline signer. Okay, so we have the offline signer, so that's this device which holds the private key but doesn't have network access, yes. And then we have the watch only wallet, so that's this thing for us here. It's watch only because it has the address and it can watch the on-chain state for that address and it can create transactions, but it can't sign them because it doesn't have the private key. So in order to send transactions, first get the addresses via QR code. Yeah, we did that. Then we generate the unsigned transaction, send it to the offline signer to sign, and then we sign and provide the signature back to the watch only wallet, and then the watch only wallet with the signature can create the transaction, add the signature to the transaction and perform the action, like, you know, send the transaction to the blockchain. That's how it works. We have animated QR codes. I didn't see animated QR codes yet, only when we read all the wallets. Those seem pretty static, but you know, for signature, I don't need more. If it's a big transaction, maybe I need more data than I can fit in one QR code. The BCUR defined by blockchain commons. All data are encoded by CBOR. I don't know what that is. And the CDDL is the data definition language for CBOR. Okay, so there are a lot of things to unpack. For more information about this, let's check this. Okay, let's check this. Uniform resources. Oh, that's what we see here. This UR is probably what this says. Unified resource. No, uniform resource. Encoding structured binary data for transport in URIs and QR codes. Deliberately elite wireless networking capability. Many device makers have settled on QR codes. Yep, so has Keystone. The largest QR code in version 40 consists of that many pixels, so we can transfer almost 3000 bytes. And then it becomes an issue if we have longer messages. QR codes support an alphanumeric mode optimized for efficiency to convey a subset of ASCII with those characters, but we're missing essential characters in here. So if we wanted base 64, we can't do that because we don't have upper and lower case. And here they try to do a standard for, combining those with this UR. Okay, so we have tags that corresponds to some hex. Finally, when we encode it as a UR, it's this. Okay, so we have some kind of data, and then we serialize it to hex, and then we encode it to this UR, something like that. And the encoding, if it's a single part message, then we have type and message. That's also what we see here. We have type / message. Type, UR double point type / message. So that already checks out. We have the type and the message. That's what we saw. And then if we have a multi-part, we can have a type, a sequence, and the fragment of a message. And that's how you would encode the sequence. We don't want to go with multi anyway. Probably we don't need that. We just need a simple UR type message kind of a thing. At least that's all I'm seeing here. And I saw also there are libraries that can do that for us. What do we have? Swift, C++, Python, Rust, Java, C++, Arduino even, Dart, I don't even know what that language is. And TypeScript. Nice. I guess we go with TypeScript because that's what we used to. You know what? I'm just gonna play with it. PNPM. Oh, you have a yearn ad? Nah, we got used to PNPM. Okay, let's see if that works. Do I want to stay that big? Yes. So it finds that. It does not find that. Has no member. You have a UR decoder and a UR encoder though. UR it finds. Okay, but then I can't do registry. You know what? Forget that example. We're just gonna play around with what we have. We wanted to decode. We have a decoder dot decode. Well, isn't that amazing? And you get a message string. Yeah, well, what's gonna be the message? Obviously this thing there. Or maybe let's do there. You give me a UR, and my UR has a seaport. Let's just print this. Let's print this and see what it is. We have a UR with a type sol sign request. That checks out. I mean, it decoded the type correctly. And then I have a buffer for the payload. Okay, what can I do with this? Cbor. That is just getting out this buffer. Okay. And what's the decode cbor? Then, oh, look, that's if I decode this buffer. So maybe that's what we saw here with we first have the hex. So that's the cbor, that's what I had in the buffer. And then if we decode it, then we have something like that. I saw that, one double point is a buffer. 2, 3. 3 has a 1 and a 2. And then there's a 6. Do I need to understand this? Where's the 4 and the 5 gone? That's a prank where you label the pigs, but you leave out one number and then they keep searching for it. That's what that reminds me of. But anyway, so that though looks very much like my derivation path. 44 hardened, 501 hardened, 1 hardened, 0 hardened. On Solana we always harden. I guess that's what that means. I have no idea. Yeah, that could be a derivation path. And that I have no idea what it is. And then we have 2 buffers. So let's get this out. Let's get the decoded CBOR though. But it's still a, what does that even stand for? What is it? Concise binary object representation. Loosely based on JSON. CBOR.io. Do those numbers represent types? That's how it defines the lengths of stuff. You can also define it with indefinite length and then break. Okay, let's not dig too deep here. So there are specs for all of that, but as long as I can somehow decode that, I'm fine. My question is now still, what does that mean? Do you put that in an object just so I have it sequentially? But then again, where's the 4 and the 5 gone? How do I know what that is? Maybe we find info on that here. CDDL for key path. Key path for derivation key? Sign request? Or maybe here. Could that be 1, 2, 3, 4? And then here could be the missing, but no, that also doesn't make sense. Then the signature, we get a request UID and the signature. Do we want to check the signature? Was this part? What do we get here? I mean, here you get a Sol signature. So far, so good. Oh, I'm not logging this. Ha. There we go. So that's the blah, blah, blah hex stuff. And then we get 1 and 2. 1 and 2. 14 more bytes. So decoded, can I just say, give me 1? Yeah, then we get the buffers. And from the buffer, I just want the length for now, because I want to know if that's 64 bytes. It's 64 bytes. The second one is 64 bytes, which is exactly the length of a Solana signature. Convenient, eh? So it could be something like this, where we get as the second part the signature and the first some request UID 16 bytes or whatever. I would really like to see the proper spec for like Solana. Do we have something like that? But that's Ethereum. We have that for Solana. Solana QR data protocol. Well, that's much better. Same premise, I guess, as the other thing. Then here is key path, derivation key. There, a Sol sign request. That's what I'm looking for. That's exactly what I need. Wonderful. So we have a request ID, optional, then sign data, derivation path. Oh, that's a tag. Crypto key path tag. And then, oh, see, and there is that's where the 1, 2, 3, 4, and 5 might be gone. There is no text and there are no address bytes. But the type, the integer, sign type transaction. The type we saw was 1 or something. What was it? Request UID, which is the UID, the sign data, which is the bytes, which is this. Then the 3 was the derivation path, consisting of those two things, which I don't know. It's probably in this tag, but I don't know where the definition of the tag is. And then there's no origin, no address, and the type is 1, whatever that means. Oh, I see. We have sign type transaction or sign type message. Nice. If we want to sign a message, then it's type 2, and this that we have a 1 here means that we're signing a transaction. So that's that. Cool. And then the CDDL for a Sol signature is the request ID and the signature. Just the signature and the request ID. And the request ID is probably the same as we had here. So probably this thing is the same as when we do the decode signature, this thing. This is the same as this, yes. So this is just a UID, 16 bytes of some ID, whatever, and it just mirrors it back. Nice. So we put a UID in here and we get the UID back plus the signature. We're already understanding what that is. That's the signature. And we understand what that is. That's important, by the way, the derivation path. We need to put that in here because otherwise my wallet doesn't know which key to use, right? It has the master seed, but it still needs to know which address of that seed, you know, and therefore it needs to know the derivation path. That's the address that it needs to sign with. And the 2 here, this, don't know what that is. Maybe the fingerprint of the master. I read that somewhere. And that's not the actual master key. It's just a fingerprint of it to identify that specific master key. And a few bytes is enough to identify it. Okay, so that means this is probably our transaction. And that makes perfect sense. Look at that. Look at that. We have a 0, 1. Wait, what's first? Signer. So comes first the message. Wait. Oh, no. That's probably just the transaction message. Yeah, it's just a message. It's not giving me the entire transaction. It's doing the transaction message And that means it's a version transaction. No. A version transaction would be if it's high. So it's not a version transaction. It has one signer, writable signer. It has 0 read-only signers. And it has 2 read-only non-signers accounts. So 2 more accounts, which would make sense. The system program and the target. Wait, no, because one of them is writable and the other one is not. Not so important, but it kind of looks like it could be the beginning of a message, and then I don't know what comes next. 4 then accounts and then a block hash somewhere. But that looks like a transaction message to me. Should we try and decode that? That would be fun, huh? Because the signature, there's not much to decode. It's literally the 64 bytes that is taken as a signature. But this guy, this is a transaction message. Install the Solana kit. Let's decode the request some more. Get compile transaction message decoder, maybe? Message is decoded number 2, I think, right? Number 2, yeah. It takes the buffer as well. Okay. That will give me a compiled transaction message. Let's see if we can get to that. Look at that, it just takes it. So, and here's the header. Here's the correct one. Oh yeah, that makes sense. We have 2 read-only, and those are the 2 read-only accounts, the system program and the compute budget program, leaving 1 more account because we get the number of accounts as well, right? We have the number 4, which is 4 accounts in total, which means if we have 2 non-signer read-only, so the sum of those 2 is the number of read-only accounts. And if we just have 2 read-only accounts, means that the rest that is on top here is writable accounts. And one of them is a signer, the first one, and that leaves this one as a writable account. Yeah, that makes sense. Okay, so this is a writable account and those are read-only. That makes sense, knowing your transaction compiling. And then we have a block hash, so the lifetime token. Then we have the instructions to the compute budget program with that data, to the compute budget program with that data, to the system program with that data, and that then 02 is a transfer of that many lamperts. Wow, and that's the transaction. Isn't that cool? We are getting somewhere. So I would say next step for us is to go the other way. What we're gonna do next is build our own transaction. First, let's actually do the difficult part of how can we get from this message to a UR thing again, to basically this message. So we now have just this message, which is this buffer, just the bytes. And then I want the UR encoder encode single part. Yeah, single part will be fine, I hope. You need the UR encode single part of my UR. I mean, this is cheating a bit because we take that, decode that, and then we encode that again. You know, I like to do stuff step by step just to see that that is actually working, that part. And then we get this UR sol sign request. And see, this stuff is case insensitive. So in the QR code, it's all gonna be uppercase letters. If we have it for a URL or something, then it's going to be all lowercase letters, but it doesn't matter. It's always with those few characters case insensitive. So that works. Is that thing what we decoded here as CDDL? I'm going to call it like that. So from that thing, I want to get to a UR. Let's see. UR. There's a from buffer. From buffer. Buffer is the CDDL that I can then put in here, right? Does that still work? This one is a UR bytes. But also the bytes themselves are different. Well, here we have the pipeline. So we have the COR encoding, binary representation. Then we have the hex encoding. Binary data is converted to a hexadecimal string. Then we have the byte words encoding. Hexadecimal string is converted to a byte word string. And the CRC32 checksum is added. Then we have the UR encoding. Byte word strings wrapped in a UR string. CBOR data, and then our type. Let's get it from the old one, just CBOR. in the hopes that we get, invalid type. My type that I'm putting in is not a right. I can't do uppercase, of course. Our type. That's how I would need to do it. Yeah. And then we get our type and the OXA ending with NDSF. That's what we saw before as well. Okay, so at least that works, but okay, we literally took it 1-to-1 from the data above, which is still cheating. We still don't know how we get from this stuff that I probably wrongly named CDDL to this whole data. This is the difficult part. It's mainly difficult because the docs of this are just wrong. If the docs are wrong, maybe the tests at least are right. You know, I complain about the Solana libraries sometimes, but there are certainly worse libraries out there. And yes, it's my own fault that I'm trying to do this with TypeScript. I could have done it with anything else, but you know. And I'm just playing around with this library that isn't easy to use. Oh, is that annoying. Wow. I didn't imagine this to be so difficult. And that's the boring part. And now we're getting somewhere. Just using a different library. Yeah, that looks like a good idea. If we decode it with that, it looks like this. We have a map of 4. 1 is tagged. Tag is this. Value is this. Error is this. 2 is this. Tag map 1 is an array. 2 is this. So it's a different representation of what we had before, but it's decoded the same thing. Here we have the transaction message, and maybe we need this kind of a format to then encode it again. And if we encode that again, still get this. Oh, but this is the NDSF. Wait, hold on. This looks better now. We just need to use the same library to de and encode. Then we get this thing, and then we have the A401. That now is the same as this now. Okay, we're getting somewhere. What, this is taking a while. Okay, but we are getting somewhere. We're just using this library to decode. And now this decoded map somehow in here can be anything. Okay, how do I access that? How about number and any? Not like I care. And then I can get to. Should hopefully get me this buffer. Yes! Cool, so that's the buffer. Nice. Wait, so. And if I just write 8, 2 at offset 0, pretending that we need 2 signers, and then I decoded set number 2 again to this thing, although I'm not sure if I would need to do that. That might be a reference anyway. Yeah, then the encoded is also different. And let's name it correctly, namely sol sign request. Probably an invalid type, and I need to write it lowercase because that library sucks. And then we get this thing, and just for the fun of it, if I would now put that as a modified message, and I wanted to decode the modified message, what would I get here? I would get number of signer accounts too. So it did work that I changed this byte in here and built myself this stupid something. Okay, I have half an hour more to put it all together now. Basically, I could either do it the hard way and, you know, build the things. I see now how this decode works. I can work with this map and I can build myself this map. But if I use the exact same key, and the clean way would be to do it like that. But I ain't got time for that. I got places to be. So I'm just gonna do the quick way and just change that one thing, knowing that I could probably build that map, right? That the same way that we saw it here. This thing, I could build that. But this would mainly be a writing exercise, so leave it. I'm gonna instead quickly build myself a transaction. This is my address that I have on the keystone. And then I build a legacy transaction, set block hash, and there we go. And now we try to persist that memo. So we build a transaction, and that's all we need, this transaction message. So we have this message, so we get a compiled transaction message. So we somehow need to, there is a compiled transaction message in the kit. There we go. Sweet. just to see what that looks like. That looks like 102 with 3 accounts. That looks great. Looks amazing. I love it. And of course, here we could build whatever transaction we want. I'm just quickly choosing a memo because I have that at hand. But you know, I could do whatever. Now I have those message bytes, and all I'm gonna do is, you know, the same thing I did before. I'm gonna cheat and decode what I already have. And then instead of getting this, I'm just gonna set the transaction message, the message bytes, as this second element of this map of this decoded one. I'll call this the... Then I encode that again, make a UR with sol sign request, and print that as my message. Let's see if we can get that far. Yeah, but we can't, like, for now, this doesn't mean anything yet. How can I get this into a QR code? I love ChatGPT because you will just tell me what to do. Want to see how that QR code looks in... Whoa! I mean, fun, but too big. Ha! And suddenly it looks like a QR code. But hey, that actually work. Although it's a bit... Would my phone be able to read this? Yeah, you would. Look, sol sign request. And this is lowercase letters. But I guess that's fine. It will just, you know. Okay, question. Would this thing be able to scan this? Invalid QR code. Oh, damn it. QR code data not recognized. Please try again. Ah, but that sounds like it got the QR code, but the data from it is not okay. What's the difference though? Let me, hold on. First of all, let's try it with a file because it's easier to work with, I think. Yeah, whoa, that's a big QR code, but it's probably gonna be the same thing here. Yeah, invalid QR code. It looks okay to me. Let's see if I put this thing in my decode request. I can also decode this. That looks fine with the memo program. That seems fine. It's possibly really just a... What's the difference between this and this? Or wait, this and this? It's a, this is uppercase. So how about to uppercase? Try that again. Then it's uppercase. And then if I scan this, it will be uppercase. But maybe the type of QR code is still different. That could still be. I mean, I don't know what type of QR code I have here. Scan it. Invalid QR code. Maybe it needs to have a specific type of QR code. So this is not as easy as I thought. I have a different question. What if I put the exact same sign request message? Could you read that? That you can read. Okay, so it's not the QR code that's the problem. Because here, look, I could transfer the 0.9 sol. So that's not the problem. Maybe the issue is that it doesn't like a random transaction like this. So I decompile the original message and then I basically just set a different block hash. And then I do the same steps with I compile it again and I set it and put it in QR and make a QR code from it. So it should be a very similar message now, a very similar transaction. And I hope that this very similar transaction I can scan. This is also already invalid. As soon as I change something, wait, what if I change nothing? What if I don't do anything with that message and the decompiled original message I compile again and I put in here? Would that work? Even that is an invalid QR code. What is different? The one thing is the buffer and the other thing is probably a uint array. Yep, that's a uint array. Probably there is my issue somewhere. I'm setting the message bytes and this is not a buffer. Okay, hold on. Buffer from you be a buffer again. What now? You take it or you don't take it? You take it. Maybe that was my bug. Maybe I just had a bug of I was using a uint array instead of a proper buffer. Okay, so revert. Do this thing. Do this thing. Let's try again with the buffer. put all of that data into that QR code. Now that we can build a QR code and try again. Let's hit that scan thingy. Look at this. It says, notice, the account's instructions will be affected by this transaction. Please review carefully. And then it shows me the actual instructions. It says the data and the program address, and it says compute budget, compute budget. And I can sign this, and it will produce me a signature. Nice! We are getting somewhere. I can now add my memo again, do this again. But with my process here, this will be very slow because then I need to go here, then I need to go here. But here I can scan this. Look. I can scan this. It's loading and it's telling me the accounts and instructions will be affected by this transaction. Please review carefully. Isn't that fun? It's the overview and they even get details with accounts. I actually quite like this. That you don't really see, but like, wait, hold on. I get all the information that I also have in there. It basically decodes the transaction and shows me that transaction, and then it gives me an overview here as well. So that's pretty cool. So I can swipe and then it will produce a signature. Scan the QR code with your software wallet. So that's that. Now I need a way to scan. Well, this is gonna just take too long. I might need to do a transaction with a durable nonce, because otherwise this will just take too long. Because I will now need to go here, scan this, copy this, go to my shared document, paste this, and then somehow, if I have this signature, then I need to get this signature into here as well. How would we get the signature? Let's build a send transaction with the request and the signature. I'm also going to decode myself the transaction again from the string. And that's a good practice anyway. We have a compiled message and we will have a signature. In the decoded signature 1, we have the buffer for the signature. And then now comes the part where we learn something. I have a compiled message and a signature. How do I add a signature to a transaction with the Solana kit? This is now Solana related again, finally. How would I do this? Read-only uint8 array is not assignable to transaction message bytes. I mean, it is the right type, kind of, but it's not the type that TypeScript wants. Sometimes this is so annoying. How do I get to this transaction message bytes? How? Okay, here we go. This is a transaction now. This has message bytes and signatures, because that thing, this won't have anything to actually partially sign with because I didn't put any message signers in there. That's how we get to the message bytes. Ugly and probably not the way how you should do it. The message bytes now as the correct type, transaction message bytes. Just to get that type, you need to go through that function. First decompile it. It's a bit ridiculous, but okay. And the signatures are just null. Okay, but it knows that it needs that signature, so that's cool. How can I now manually add that signature? What you need is signature bytes. And to get the correct type for here will also be a challenge, because I guess you don't like just any bytes. You want them to be signature bytes. You motherfucker. I hate types. I like the kit for building stuff, but once you want to work with bytes or low-level stuff, those types just really mess with you, and it's so annoying. I hate types. This should be super easy, but it's not. Feedback for the kit, but the kit also doesn't try to be easy to use. It tries to be efficient. How can I create a signature map myself? I want to create signature map, a constructor, but no object orientation here. No, just functions. This is getting annoying. I have the bytes. I know what I want. I want to just force in a signature into this transaction object. How can I do this? Just grab it, smash it, and really force it in. This can't be so difficult. It is very difficult. The kit is making it very difficult for me right now. I have the bytes, and there is a get signatures encoder. Why do I not get this one? Why is this one not exported in the kit? Why do you keep that private? 0s signature bytes. It just takes this as signature bytes. That's how easy it should be. So we have our signature buffer, which just say uint8 array as signature bytes. But then how do I get a signature map? Maybe it was a mistake, and maybe it wasn't. This is an object. You think that's gonna work? I have a feeling that this is not gonna work. But hey, I mean, not really? We have the message here, yes. We have something here. Wait, is that 32 bytes? No, because the signature bytes are already just 16. Hold on. Am I getting the wrong thing for the signature bytes? Yeah, the second element, not the first. But hey, that means it's getting in there correctly. And now, wait, that was also wrong. Oh, I have a copy-paste error here. But now, I'm just already very tired. Now that actually looks like a transaction. I have one signature, damn. And then I have the message. That actually looks like a transaction I could finally send now. Let's just check if that would be an actual transaction that I could parse in the Explorer. Yes, and does the signature check out? Fuck yeah, the signature is even valid. Nice. So I built this together correctly. This works. Took me forever, but it works. So then we just need to send it, and for that we need an RPC. You now need a fully signed transaction. You know what? My ass. As fully signed transaction. Damn it. Still not. Okay, as fully signed transaction and transaction with block hash lifetime. I'm not gonna let your types annoy me. Go to hell. And you need a commitment. Process. That's enough for me. Ugly code because I'm just typecasting everything as I need it, and I encode such that I can decode, which is so useless. You know, I could wait, forget that encoding, and I don't need that. Then I can say transaction. Okay, a little bit less ugly, and really I just need this. So basically what I'm always doing is I take the thing that I have and just say it is a signature bytes, and it is a signature map, and this one, it is a fully signed transaction with a transaction block hash lifetime. You know, kind of a trust me bro approach. You just gotta tell the kid it's fine, kid, you have the thing that you want here, don't worry about it. And then it will just work. Okay, it's a bit, you know, it's a bit annoying, but you know, it's okay, it is as it is. Okay, and then we can send and confirm and log the get signature. Wow. Now, such that we can actually do this, I gotta send a different transaction though, because otherwise I need to be super fast, and I'm not super fast. So we gotta need to do a nonce transaction. So, practice how to do this. Can the CLI create a nonce account? Create nonce account, yes, wonderful. Take all my sol, I don't care. So we have a nonce account with the following block hash. Let's practice doing a nonce transaction with the kit, because I've also not done that ever. So first of all, we will need the program system. The first instruction needs to be a get. Oh, hold on. Wait. I also need to set the authority for the nonce account, authorize nonce account, and the authority pub key. There we go. If we refresh this, the nonce account belongs to this guy. Wonderful. Nice. Okay, that was important. Nonce authority needs to be a transaction signer. How do I do this pseudo signer? Create no op signer, because we're not going to sign with this, but the types require this to be a signer. So there you have my pseudo signer. That's a neat little trick as well. We're learning tricks about the kit in this 10-hour long video, or is it just 10 hours for me? Maybe I cut it properly for you. Okay, so that's an advanced nonce instruction, and then the memo. Then we just need to set a different lifetime, set message lifetime using durable nonce. And what do you need? The nonce address and the nonce authority address. RPC and address. Oh, that looks nice. I just give you the entire RPC and you fetch me a maybe nonce. What if I don't say maybe? And then I get an account nonce. Authority, block hash, Lampert's per signature. Wonderful. So that stuff I can now use here for data authority, nonce itself, block hash, I guess. It doesn't like all of that because I'm missing a comma. I'm missing the transaction. The nonce. How do I get that? Should we do our stupid trick as nonce again? How is block hash an address? I mean, for real, how is the block hash an address? That doesn't make any sense. Why is that not typed nonce? I mean, this I think is a bug. Did nobody ever use this? I hate your types. Hate them. It's gonna work anyway. Correct types are overrated. So, we set the lifetime using durable nonce. We append the get advanced nonce instruction. Compile this, put it in a UR, put it in the CBOR map, create the UR from it, create the QR code from it. Many steps. Let's see if that will work. Build transaction request with nonce. It let me create that. I have a QR code. Do you think this thing will allow me to scan it? And overview. System program advanced nonce account. System advanced nonce account. It shows me 2 advanced nonces, which is probably just a keystone bug, or like it just doesn't decode that properly. In the details it's correctly decoded, so that's what I would look at. And now I can swipe it. No, I can't. I swipe it and I can't enter password again, but at least now I have time, and this is the signature. Now scan this, copy this, paste this, take this, I paste the signature. I'll also need to paste that for the actual transaction, and with those 2 pieces of information, my send transaction should now be able to actually send that transaction. So advance nonce account, nonce can only advance once per slot. Okay, hold on, 1 step back then. Let's check the transaction in the inspector. This thing, it has a valid signature, so we managed to get the actual signature for this signer of the thing. So that's already like, that's how far I wanted to get. I just didn't manage to actually send it yet, but that already looks good. Let's check. Wait, there are 2 system program nonce advance instructions. That's why I get this error, because I'm trying to advance it twice. Oh, is the kit so smart that it adds that instruction? I think it adds that advanced instruction when I set that message lifetime. That makes sense. Wow, okay, I've never tried that. Okay, and so it ensures that that's always the first instruction. Okay, so then that's also no problem with GIL, as I thought because they do the compute budget stuff. But anyway, so then that basically just means I don't need to set this. Since that already returned success, that seems fine. So I just don't add this. Good to know. Good to know. The kit takes care of it if you let it. So the whole thing again, we build with nonce. We scan it. Oh yeah, that's much better. Okay, so it wasn't a bug with my keystone. It was just me actually providing those instructions. Swipe and get transaction signature, scan transaction signature, copy transaction signature, paste transaction signature, copy transaction signature, paste transaction signature, copy transaction, paste transaction. I need to do this because I need to have the correct block hash, even though actually in that case the block hash should have stayed the same, but anyway, I copied. And then if I send transaction, are you kidding me? Why? Why did I do this to myself? Why did I do this to myself? Why? This is so stupid. Why did I limit myself to 5,000 compute units if I log that much that needs more than 5k, it's definite. Make it 500. Oh no. And the whole process again. One day I will manage. I could simulate it first, but no, it's gonna work this time. I tell you, it's gonna work this time. It's gonna work. So sure about it. Now send it. Send it. Cannot read property of undefined last valid block height. Transaction lifetime constraint, last valid block height for the waiters. Oh, because it's trying to wait for it with the last valid block height from the transaction, but the transaction doesn't have that. Well, that's on you. That's on you, kid. Then you don't confirm it. Not like I care. I'm just gonna check the signature here. Look. The undocs, send a transaction with the nonce account, the system program. It has an advanced nonce and it has an instruction to the memo program. Look, this is amazing. It worked. It finally worked. Wow. I mean, how long did that take us? 6 hours. Took us 6 hours to get here, but we did manage to freaking sign any kind of transaction with that thing. We know how it works. And it was super annoying because of the libraries I used and I just didn't know how to work with them properly. And also the Solana kit makes it somewhat difficult until you realize that if you don't have the type that you need, you can just say, well, make it that type. Just be like, yeah, it has that type, just we have those types. Once I realized that made it much easier. So yeah, that's another tip for you. If you work with a kit and you do some weird hacking, just pretend you have the types if you have the right data, but just not the right type. And that was actually easy. It's easy, right? So easy. And now I can totally send any kind of transaction air-gapped, even with nonce, because I need some time to do it and it's still a bit complicated. So I do actually prefer to have, Solflare just create me the QR code that I can scan here. That makes my life much easier actually. But if for some reason I can't use Solflare, I can now build the transactions myself the way I want them. And that I think is really cool. One could even say it's amazing. Yeah, fuck it. Watch some other videos, like it, subscribe. I gotta go to sleep and rest my brain from this endeavor. I am tired, but still, I managed. I did manage to do the thing that I wanted to do and send a freaking transaction, from my Airgapped Keystone wallet. Pretty amazing. Now scan this.